Okay, relative motion. So these type of problems, they're always going to be something to do with wind or current. So you're going to be in a plane, or you're going to be in a boat, or it's going to be a bird or something like that, right? Going through the air. All right, so what we have to do now is add the the current to the velocity of whatever we're talking about. So let's just go ahead and do example number 2 here. It says a bird flies at 50 kilometers an hour in an area where wind of 40 kilometers an hour is blowing east. What is the resultant velocity of the bird when it flies east, west, and north? All right, so we got to get some terminology kind of under our belt here, though. So this says the terminology for vectors, and it says BVA. And what that means is the bird's velocity relative to the air. So it's always going to be the velocity of the thing, and then relative to and that's what comes after. And just to make sense of that, I'll kind of show you what I mean. So when it says bird's velocity relative to the air, well, that's going to be this one. That's going to be a bird flies at 50 kilometers an hour. So we're saying it's going 50 kilometers an hour just relative to the air around it. So that's always going to be, yeah, like what you would think something could do if it was totally calm. If there was no wind at all, that's going to be that one. The second one here, it says AVG. That means the air's velocity relative to the ground. That's just the speed of the wind, right? It's just saying how fast is the wind going relative to that thing that's not moving, the ground. The last one says BVG means the bird's velocity relative to the ground. So that's what we want to find, right? So if this is how fast the bird can fly, this is how fast the wind is blowing, how fast is the bird going in the end? That's what bird's velocity relative to the ground means. Hopefully that makes sense, because I know these it's kind of like a tongue twister almost sometimes trying to figure out what it means. But try your best there. So it says when the bird's velocity relative to the air is added to the air's velocity relative to the ground, the resultant velocity is the bird's velocity relative to the ground. So kind of like what I just set up there, right? So we need to just add the two. And this looks all confusing, but all we're doing is really just adding the two vectors. So we've got the bird flying east, so it's going to be positive. Sorry, the bird flies east with a 40-kilometer east wind. So that means step number 1 here is we've just got them going in the same direction. So we're just going to add them. We've got positive 50 plus positive 40. So the bird will be going relative to the ground 90 kilometers an hour. And we got a positive number, so it's going to be east. The bird flying west. So now it's flying into the wind. Now this is the bird's vector, the bird speed. The wind is going that way. So really we need to end up subtracting them, right? So now I've just got 50 kilometers an hour west plus 40 kilometers an hour east. Well, west was negative, so in the end I had negative 50 plus 40, I had negative 10 kilometers an hour, which means it's west. The bird flying north when a 40 kilometer an hour east wind is blowing. Now we got to do trigonometry, right? So we've got the bird going north, that's this vector, and then the wind still blowing the same direction. So we need to use our trig identity to figure out what the angle was. It ends up being east of north because the angle is like coming from the north, remember? And then use Pythagorean theorem to figure out what the magnitude of the velocity of the bird relative to the ground is. And then you write your answer out that really long way like that. All right. All right, so here's a pretty standard question that you're going to get to. So it says a plane flies north at 300 kilometers an hour, but the wind is blowing at west 70 kilometers an hour. So it's blowing toward the west there. So you make your triangle again. We're going to figure out our angle using trig identities like we did in the last lesson. We're going to use Pythagorean theorem to figure out the magnitude. And that's it, pretty much the same as we just did above. Now, this part's a little bit different though. So it says the wind is the direction causing the plane to go off course. This is part B. So how far off course will the plane be after 3 hours? One thing to recognize here is that all of this relative motion stuff that we're doing is only going to use one formula. It's going to be V is equal to D over T. And just think for a second why that's the only formula. Well, that formula is the only one that deals with constant velocity. The rest of them that we've done so far have all been dealing with accelerated motion. We're talking about like a plane flying at a constant speed, a wind going at a constant speed. So that's the only one we have to deal with in these type of questions. Okay, so we rearrange that formula and we get d is equal to v times t. And then we've just got 70 kilometers an hour west, so that would be negative if you're putting in your calculator, times 3 hours, and we get 210 kilometers an hour. It'd be negative for an answer, which means west. Now these ones kind of play with kids' heads sometimes. So I'll just walk you through it. So it says city A is 600 kilometers an hour, or kilometers. Let me try one more time. City A is 600 kilometers south of city B. So if this was B, this would be A down there. An airplane which can fly at 200 kilometers an hour relative to the ground, or relative to the air, sorry, must fly from city B to city A. A west wind of 90 kilometers an hour is blowing. So when it says 200 kilometers an hour relative to the air, that just means that's how fast the plane can go, and this is the speed of the wind. All right. What's the required heading? So you need to be able to draw your triangle out properly here. Before, what we had was that, the other situations was, we had the plane going straight north and then the wind going straight, like, they're going that way. Now what's going to happen, though, is that I know that I need to point my plane in a certain direction. So that's this arrow. So it's got to go off on an angle first, and then the wind has to bring me back so I can fly my plane in a straight line down. Hopefully that made sense. So this is now the resultant vector. The resultant vector up until now was always the hypotenuse of the triangle. Now it's the adjacent side of the triangle. So that's going to be a little bit different. Your hypotenuse is actually your plane relative to the air. So that's this one, right? So practice making those triangles, because I know everybody gets that a little bit funny when they're trying to add those together. Okay, but then once you get to this point, once you've drawn it, it's pretty much the same thing. So well, you've got a right angle triangle. You got to figure out what this angle is. It ends up being 26.7 degrees. And then if you drew a little Cartesian plane there, again, it's going to be west, and it's coming like of the south, I guess you could say. So west of south. And then we got to use Pythagorean theorem to figure out how fast the plane will actually be going in the end. So that's this velocity, right? So now we need to point our plane in that direction, but the plane actually goes in this direction. That's what's happening here. And we just figured out the speed that it's going to be going in that direction. And we wanted it to go straight south, so it's going straight south. And the plane travels, or sorry, what was C? How long is the plane, or is the flight from city B to city A? So now we only know one formula. So you just need to rearrange for T, figure out your distance. It's 600 kilometers away, and we know that the speed is 178.6 kilometers an hour. So the time is 3.36 hours. So example 5, this is the classic riverboat problem. This one's not a boat, there's a girl swimming across, but pretty classic. We are actually going to do in the practice problems one pretty similar to it. Oh, actually, no we won't. I'll go through this one. So it says a girl standing on the west side of a river that flows from north to south at 1.5 kilometers an hour wishes to swim straight across from point A to point B on the diagram. She can swim at 3 kilometers an hour in still water. All right. Okay, so getting our info here. She's on the west side of the river. She wants to go this way, and the river flows from north to south, so it's going down, right, at 1.5 kilometers an hour. This is one that kind of confuses people. She can swim at 3 kilometers an hour in still water. So that's going to be what she could swim at, right? So that's going to be the one I need to point, or she needs to point herself up the river, and then that's going to be her speed right there. So that's the velocity of the girl going that way, and then velocity of the river going down, And then hopefully, well, it should be with proper math, she's going to go straight across the river if she points herself on an angle like that. So we're going to do the same thing. So now we're going to use our trig identities, this time sine, to figure out your angle. So 30 degrees, and it's going to be north, and it's of the east. So north of east. Figure out your speed that she's actually going, or the velocity that she's actually going. That's 2.6 that she ends up going across the river. And then last thing, the time required. It's going to be the length of the river, or the width of the river, I should say. And then the velocity that we just figured out. And that ends up being 0.096 hours. You can convert that to 5.76 minutes. Okay, so I'm going to end that video there, and I'll see you guys in the practice problems.